All right, so a very informal definition of continuity is if I can draw it without picking up my pencil. So if I could draw this graph without ever picking it up, then it's going to be continuous. So x squared graph looks like this. So that's a continuous function. 1 over x, though, looks like this. So this one is not continuous at 0, because that's where the break happens at. I can see the thing is really slow. Okay, now it just caught up to me. This one, so when x equals 2, I have a dot right here. Put in the bucket. So when it's not 2, let's see, I got a slope of here. And then here. So it jumps right there. So this is not continuous at 2. This one right here, we have talked about before. You'd graph an x plus 1, x minus 1, or x minus 1. The x minus 1s would cancel. And I'd be left with x plus 1. So you have a line like this. But we have a hole where x equals 1. So make a hole there. So that one, do you see how I had to pick up my pencil to draw the hole? So that's not continuous. So this one, the top one is. This one is not continuous. Let's see, it's not continuous at 0. This is not continuous at 2. This one is not at 1. And then this one down here, let's see. I'm not exactly sure off the top of my head what this one looks like, so let's just go ahead and graph it. So I have the function of square root of x minus 1 divided by x minus, x minus 1. I think I put 1 too many parentheses in there. Okay, so do you see right there, like you can kind of see it down there. So I'm going to go ahead and zoom in. I'm going to make my x 0 and then y min, just to get a better picture of it. So right here, you can't see it in the function, but there is a hole where x equals 1 at. See, there's no y value when I checked in my graphing calculator. So it was a function that was starting here, curved down, created a hole, and kept going. Since I had to stop to create that hole, that one is not continuous at 1 also. So the formal definition of continuity is that you have a y value and that the limit exists and that the limit equals the y value. So we're saying the limit from the left equals the limit from the right is continuous. So we would say this right here, is it continuous at a point f equals c? So I could say, is this continuous at 2? And you could say yes, because f of 2 would be a half. And the limit as x approaches 2 of f of x would equal a half. Since these are the same, it is continuous then. But if I asked you at 0, you would say no, because f of 0 is not defined. So it failed number 1. So this one is not continuous at 0 because it fails rule number 1 right there. For this one right here, f of c does exist this time. So let's say, so f of 2 equals 1. But if I do the limit of 2 from the right, I get 1. But the limit as we approach 2 from the left, that equals negative 1. So these two aren't the same. So the limit of f of x does not exist. All right, these aren't the same values, so that's why this one does not exist. And this is a formal definition of how you would show it. This one right here, the y value exists, the limit's going to exist, but they're not going to equal each other. Oh wait, the y value doesn't even exist. Okay, just kidding. So f, oh it does, f of 1, oh f of 1 does equal 1. Why is it open? When x equals 1, it's 1. So it looks like that maybe. Is you plug in 0, I get 1. Yeah, so I guess it's supposed to look like that. I think they missed the dot. So f of 1 here exists. It's 1. It tells us so right there. And my limit from the left and the right as I approach 1. Let's see. I plug approach 1 from each of these sides. I'm going to do I think we're approaching a half, if I remember it correctly. And all I was doing was like trying numbers in my calculator to make sure it was a half. So I plugged in like 0.99 on top and bottom, and it's definitely getting close to a half. So I'm pretty sure I thought I could prove it mathematically too, but that's a little advanced right now for you guys. So because these two aren't equal, 3 is not right. So 3 fails because the limit does not equal the y value. So that's why this one is not continuous. So find an a that will make it continuous at 2. So that would mean if I plug in 2 into the top and 2 into the bottom, I should get the same y value out. So if I plug in 2 there, so the top value is 3. So I have 2, 3 on the top. When I plug it into the bottom, I have a minus 2. So I need that to equal 3. So if a equals 5, then these two have the same y value, so it's going to be continuous. That's what makes this one continuous.